So Hemant, could you please explain about this particular device?
Yes. This is a rectangular pyramidal horn antenna, and the main part of this horn antenna is this waveguide.
Yeah.
This is a rectangular waveguide.
Okay.
Have a dimensions of 50 mm by 120 mm.
Okay.
And the length of this waveguide is 110 mm.
Okay.
And this is fed using a coaxial connector.
So this part is the coaxial connector.
Yes, this is a coaxial connector, and we can see inside this we have fed using a probe.
Yep.
This one.
Okay.
And this probe have a length of around lambda by 4.
Okay.
So it's working as a lambda by 4 monopole antenna.
Okay.
And the aperture part is this length of this aperture. You can say as a width.
Yeah.
Wider dimension of the aperture is around 450 mm.
Okay.
And the narrower aperture dimension is 320 mm.
Okay.
And the length of this flaring,
the flaring
total
part,
is so it's a 250 mm.
Okay.
And the length of this waveguide is 110 mm.
Okay.
So the total length of this antenna is 360 mm.
Okay. Okay. This is mainly used as a reference antenna.
Yes, this is mainly used as a reference antenna for GSM and CDMA band.
Okay.
So to measure the radiation pattern and gain of any other antenna,
Yeah.
we can use this as a reference antenna.
Okay. So Rinki, could you please explain a little bit about this device?
Yeah, so this device is conical horn antenna.
Okay.
So in this device, basically we are feeding with the help of circular waveguide.
Okay.
So this one is the part of circular waveguide.
Okay.
And here for feeding purpose, we are using circular antenna. You can see here in the last device, there was monopole antenna with the help of which we are feeding. But in this case, with the help of circular antenna, we are feeding.
Yeah.
So this antenna is designed to operate from 2.1 gigahertz to 2.2 gigahertz. So
Okay.
the bandwidth that this antenna is providing is 100 megahertz.
Okay. So could you please tell us also about the dimension of this circular waveguide?
Yeah, so the dimension of this section is 11 centimeter,
Okay.
and we want it 11 dB gain. So
Okay.
for this purpose, they have provided the flared angle, and the outer dimension is 19 centimeter.
Okay. And the main application of this kind of antennas are?
So this antenna can be used for 3G standard 3G applications.
Okay. And you have also simulated and experimentally evaluated this kind of antennas?
Yes, we have simulated as well as we have measured. So we were able to validate the results with the simulated ones.
Excellent. Thanks a lot, Rinki. So Mahima, could you please explain this device, what I have?
So this is a waveguide. This is an expand waveguide. This is particular termination which we have here. So
So it's a termination because the other side is
it's
shorted here. And what are the dimensions of this waveguide?
So this is for expand. So this is about 22 mm by 10 mm. So
Okay.
this is a WR90 standard waveguide.
Okay. And what is the main application of this one?
So this is like a cavity resonator. If you short the other end, this length decides at what frequency it will resonate.
Okay. Okay. And this one is.
This is also for the same band. This is
Yeah.
a power divider. So it's
Okay.
a equal power divider, 3 dB.
So it's a 3 dB
3 dB
power divider. Excellent. So these devices you have also simulated and experimentally evaluated, right?
Yes.
And what is this one here? What we have?
This is at a slightly lower frequency. So this is an S band,
Okay.
and this is a WR284 waveguide.
Okay.
And the dimensions are, I think, about 72 mm by 32 mm.
Okay. And the main application of this kind of
So it's
units?
like high power, transferring high power from one end to
Okay,
another end.
okay.
This is actually waveguide.
Excellent. And these things, what you have here?
This is actually a tuner.
Okay.
So we can slide this shorting post to and fro and get various impedances on the other end.
So basically, you can move this part up, and then
yeah, slide the shot.
you can slide the thing.
Yes.
Okay. And the main application of this kind of things?
It's mainly for measurement kind of application. When we have a device and we want to find out what is the optimum impedance there.
Okay.
So
Okay.
there we use it.
And this is also in the expand.
Yes, this is also in the expand.
Thanks a lot, Mahima. So Mayur, could you please explain about this particular waveguide, because we just saw about this waveguides, but this is quite different. So What is the dimensions of this and what is special about this?
This is basically a rectangular waveguide.
Okay.
Its dimensions in horizontal are 22 mm.
Yeah.
In vertical dimension, it is 10 mm.
So it's very much like this old X-band paper.
Right.
So the operating frequency is in the range of
8 to 12 gigahertz.
Okay.
Yes.
And what is very particular about this waveguide, because I see that it's very bendy and it has certain corrugation.
Yeah. So in this particular waveguide, we have these corrugations to make it flexible.
So
in order for in some applications wherein we can connect two parts without the need of joint.
So, and also this corrugation basically helps in bending it without affecting the operating ranges.
Right.
Okay.
So operating band is the same, and we get the same band with some bending in this way.
Thanks a lot, Mike. Okay. So, Ramkumar, could you please explain what is this configuration of this machine?
This one is a dismantle setup wherein it can work both as motor or generator. This part.
This part.
This part is generally used when that is used as a generator. This would be used as a prime mover to drive it.
Okay. And could you please explain the reason for this configuration? As in
the sense, we generally have motors in. We can use it as generator or motor.
Yeah.
So a machine as generator or motor. So when you are using as generator, you need a source.
Okay.
To drive it.
Yeah.
We are using a variable frequency DC generator for it.
Yeah.
And the other way around, when it is as a motor, you just need to check all the parameters for which you have this panel.
And would it be possible for us to dismantle
we can
this?
remove everything which are kept here.
Okay.
In the sense, everything singles the machine can be split into individual completely small parts where you can check everything.
So could you please now dismantle it and show it to us? So Ramkumar, this is the rotor.
Yeah, this is the rotor part.
Yeah.
And in this case, you need to when it is working as a DC, you need to get the DC supply. But then the induced voltage in the coils will be AC.
Okay.
So you use commutator for it.
So this particular part is the commutator part.
Yeah.
And this one is the brush here.
Yeah, no, this might also be used as slip rings.
Okay.
So in case of slip rings, these are internally shorted.
Okay.
But for commutator, we directly connect here.
Okay. And the coils here, these are the stator coils.
Yeah.
I'm seeing that pretty much that you have different coil windings based on the rating what you're having. So based on that, you can pretty much assemble and run it. And this particular machine is used both as a generator or as a motor. And you have done quite a bit of simulation also on this kind of units, right? Yes. And what is the power rating of this device?
This one we can go up to quarter kilowatt. In a sense, 1/4.
1/4. Okay, 1/4 kilowatt. So like 250.
250 watts.
Okay, excellent. Thanks a lot.